Hi everyone, today we're looking at Module 7, Lesson 7, and we're going to be discussing infinite decimals. The two learning targets we're looking at today start with students know the intuitive meaning of an infinite decimal. So we all know that infinite decimals go on and on and on and on and on forever. And students will be able to explain why the infinite decimal is equal to a fraction. So the first example we're going to look at is example number 1. Says write the expanded form of the decimal 0.3765 or 3,765 10,000ths. And we're going to use powers of 10. So what I want to do is look at that decimal and see what place value each digit is located in. For example, the 0.3 is in the 10th place, 7 is in the 100th place, 6 is in the 1000th place, and 5 is in the 10,000th place. Now I can rewrite these denominators to be powers of 10. So 3 over 10 plus 7 over 10 squared plus 6 over 10 cubed plus 5 over 10 to the 4th. So expanded form using powers of 10, this would be my final answer, this kind of set of fractional values that we found. Our second example just says do the same with the value 0.3333 repeating. Now again, I can find expanded form using powers of 10 in my denominator just by looking at the place value. So my first place value is the 10th place, followed by the 100th place, followed by the 1000th place, and I'm jumping straight to powers of 10 here so that I don't have to write all those extra zeros. But this decimal expansion is going to go on forever because that is a repeating decimal. So we can write decimal expansions with finite decimals or infinite decimals. Module 7, Lesson 8 is going to talk to us about the long division algorithm. Now, a lot of us do not particularly enjoy long division, but if you remember the process, it's really just procedural. We have a couple of learning targets here. The first says students know that the long division algorithm is the basic skill to get division with remainder and the decimal expansion of the number. So this is going to be another way that we could take a fraction and get its decimal expansion, is using long division. Target 2 says students know why digits repeat in terms of the algorithm. And target 3 says students know that every rational number has a decimal expansion that repeats eventually. So, by using our long division, we're going to do a quick example. It says show the decimal expansion of 26 over 4. So a hint that we know to turn a fraction into a long division problem is that the top dog always goes inside the house. I don't know if you've ever heard that saying, but if you have a larger dog as opposed to a smaller dog, it usually gets to choose its place in the doghouse. So the top dog always goes in the house. 26 goes inside that division symbol. So 4 into 26 is approximately 6. Times 4 is 24. Do my subtraction and add my decimal to bring down a 0. 4 goes into 25 times, and I get a decimal approximation of 6.5. I can also do this using distributive property. So instead of just doing my long division, or in addition to doing my long division so that I can double check my answer, I can do 26 over 4 is the same as 6 times 4 plus 2 over 4. Now those 4 values cancel out. I get 6 times 2 over 4, or 6 1/2.